Okay, you can share your screen right away. Because you're on Zoom, right? So share. Join your Zoom and share your screen. All right, folks. So we are, who is presenter number 2? Mandeep, you'll be presenting? Okay.
I can present too.
Abdullah, you are also there? Okay, and Srirang. So 4 presentations. All right, guys, it's really worth seeing how we are making progress. Let's pay some attention to that, and then we will move forward. Welcome. So remember, you get out of audio and you use the, when you speak here, you have to be close to the mic.
Okay.
There's no option here.
Oh, maybe I should go to Google. Safari doesn't allow me.
You're not able to share?
No, maybe I'll go to the Chrome.
Here.
I'll go to Chrome. Maybe there's an option.
And I'll stop sharing from here just in case. Oh, because of that. Maybe.
Oh, here. Okay. Oh, it is. I do not get that top.
That option is not. Oh, don't do it through that. Use the desktop version. You're using a web version of Zoom, right?
Yes, I don't have that.
Use a desktop version.
Or I can do it. I think. Let me try. Let me see. I have a desktop.
How about this? You figure this out. In the meanwhile, we'll have this next.
Next year, so that we'll get the Zoom desktop.
Are you guys going? Abdullah, are you? Who's the number 2? Which team was number 2? Okay, you go. Oh, you also need to down. Abdullah, come by. Oh, okay. So see, try to share. Yeah. Abdullah, come by. Okay, let's give him a chance after that. Don't go through it too much. Like, just some a little bit, and then go through the app. First, do the app, and then introduce yourself. And you have to be very close to the microphone, otherwise it won't pick up. It's an. All right. You share your screen?
I'm doing it right now.
And so what I'll do is, sorry. There you are. And go ahead. Yeah. But do much closer to the microphone. It's perfect.
All right, so hello everyone. My name is Abdurrahman Kazi. This is my application. It's not fully complete on this device, It's because I used a bunch of sci-fi and fantasy books for the data collection, but it was a little too big to transfer over to this small laptop.
Bit about your data. What data set did you take?
I don't remember the exact site, but it was basically just a bunch of sci-fi. Actually, I think I have.
The sci-fi.
Yeah,
That's
sci-fi fantasy on this specific computer. I have primarily Harry Potter. So like all the books. Yeah, yeah.
It's not sci-fi.
Sci-fi fantasy, like the kind of unrealistic. Yeah, yeah. So this is my like the full data set. It's what is it like 2 GB? So I couldn't really transfer it over. This is the specific Harry Potter one. So it has a lot of chunks. Like I think it was like 1,000. No, it's just the books. Just the books.
Chunk size.
I think it's 1,000. Yeah, hold on.
Yeah. So you came up with 1,000 tokens or 10,000 tokens. Oh, chunks. How many chunks did you end up with?
What do you mean end up with?
When you like how many chunks did you index? How many vectors? Across all the bits?
Let me find the exact.
If you have it in a file, just do word count, line count. Yeah, that's the word count. I don't know why it is word count. The minus L is the one that is like.
So 1,400 around.
That's really good.
Yeah. This is just the Harry Potter one. The other one has I don't want to scroll all the way down, but like it's much more. Yeah. Um, hold on, let me go to my. I can go through the code, or should I just go straight to the app?
Yeah, sure.
Okay, so this is the instruction page, right? And I have 4 tabs. I have the instruction, I have upload file. This is you can only download the upload the CSV, but this is obviously a limit of 200 megabytes, which is why I couldn't transfer over the full CSV file. Um, yeah, the CSV file has to be in that specific format, the one Asif Uncle gave last week. There's a search. So, if I have if I search up Severus Snape and then click search, the first result that comes up has Severus Snape. So, I mean, that works. I can add new data. This is just something I added on the side. So I can give it a chunk ID and then type in just like random stuff. So I am presenting. And then I can go to the search again and then say presenting, search, and then it'll pop up. Yeah. I can go through the code now. GitHub. So, I have the requirements in a different page, but this is specifically just the Harry Potter, just saying that. So I have a specific function to read the data from a folder. So if I go to uh, is that good?
This is your Streamlit. And would you agree that Streamlit was very easy to pick up?
Streamlit was easy. This isn't the Streamlit code. This is just the Python, and then via GitHub I like connected it over. But yeah. Um, what do you want me to go over? Okay, so to read the data, I had to make like a loop function. Where is it? No, it's all the same. Yeah. I just use my brother just told me to use Distilburp, so I just use that. Um, where is it? Well, anyways, so the way it works is I have a folder, and it basically the program loops through the folder looking for documents. So I have a document folder, and then I have multiple folders inside that folder, and then I put the PDFs or the TXT, and then it'll just scan through and then just pretty much read it all. It doesn't. I don't know how to scan from websites yet, so I didn't do that. But yeah, this works fine. I I think I just used the regular yeah. It's when I so I took the data and then I transferred it to or converted it to DBF, or it's like a database file. So then it's just in one row, it's like every word, and then it's delineated with a space. So the encoding is 1,000 words, so it just separated that based off of the space, and then it encoded it, and then it went to um that's the chunk, and then I'm like forgetting what I did. Encoded it. There was some step in between, but basically the search function was at the end, then the encoding. What did I do? I can ignore it for now. No, no, no. It's just brute force naive, like you said. Yeah. I mean, just one and two. Yeah. Just you said to use yeah. I didn't say that again. 1,000 words. Yeah. Any questions?
That's the beauty of semantic. Even if you don't give the spelling correct, the machine infers it. Right? It is very good. Whereas the keyword-based search engines don't do that. Exactly. They have some of those good expenses. Amazing. Very good. Thank you. Very good. So that was Abdul Rahman, probably the youngest, one of the youngest members in our cohort. If he can do this much, I am sure you guys have done much better. Oh, right. Yeah. Oh, by the way, just to give you a bit of a background, his dad and his elder brother both have been through support vectors. His elder brother felt that he's not busy enough, so he decided to do two masters in machine learning from two different universities in parallel and finished it successfully. So obviously, he comes from a genius family.
No surprise.
That's minus 70 decibels. Voice needs to be lifted up quite a bit.
So we did phase 1 and phase 2. So the phase 1.
asking the people on Zoom if they can hear you.
Okay.
That's how you.
People on the Zoom meeting, can you hear us?
Yes.
Okay, great. Thank you. Yeah, so we are Team I1 AI. So we have Gaurish, Guru, Damu, and myself, Dilavar. And we did phase 1 and phase 2. So in the screen where we have the visuals view. So this AI search phase 1, how we have constructed ourselves is like we had a one second. Yeah. Yeah. So we had the same first one was building a corpus with sentences, and then we used a search module where when we could do it. So for example, this is the search corpus, the first one, and search module. Then we had a search module where we had what we did was we used the asymmetric search model, MS Marco Distill one. And what we did was we built the corpus embeddings from importing the list, which we had the Python list. And then we had a method where we can build the query, which has been passed at runtime using Streamlit. And then it written back. It's the simplest one. Maybe we could run it first. This is the, yeah. Takes a while to load.
Once you guys have this, actually today is getting late.
Yeah.
What I'll do is if I have all the team names, my team will start emailing you on the spot. And this is how to connect to this.
Yeah, so this is the UI. So we are trying to do a same. So here it is from the search corpus.
Nice.
It gave back the rank and the score. We limited the query results to 3. So this is from where we had.
Could you please increase the font size?
Sure.
Very long sentences. That's why you're having.
This is the same search corpus. We did not chunk it here. Already it is like chunked one. First one, phase 1. Entire. And I mean, it is like chunked in the sense like we had 16 sentences in a list. So it's already chunked, pre-chunked, right? So nothing big on this one. So this brings the results very quick. And next we'll go to the phase 2, unless you have any questions. Okay, it is simple. The phase 2 is where we went through a brute force chunking. So I'll start that one because it takes a while.
We can show the screen.
Yeah, I'll show the screen. And this is the phase 2 which we had. Where is that? It's not there. No, it got online. Yeah. Okay. I'll just kickstart it as it takes some time, and then I'll explain the code. Did you go to it? Yeah. Okay, this will take a while. In the meantime, I will go and explain the code. And our approach was we took one document from Project Gutenberg, which is the complete works of Shakespeare. And we did a brute chunking in the sense that we used a new line. So we split paragraphs. So what it resulted is we got close to around 49,000 tokens. Right? So, and our idea was as chunks, sorry. And what our idea was like, we build a CSV data store where we have the chunk ID, chunk, and the text, document ID, document title, and the actual converted vector embeddings for each of one. We stored them in a CSV data store. And then we had a code comparison. So when we did the search, we used the util semantic search one. So the embeddings we had to, since it's already in the data store, we had it, and query at runtime we did it. But yeah, so I'll walk through. So we had three modules: util, actual code base, and the data module. So in util, I'll start from util. This is an A search phase 2. No, this is the A search phase 1. This is phase 2. This one, right? Yeah. So let me reduce the terminal. So we had in this two util methods. One is to download and write it to a file, the text file from Project Gutenberg. So we had the first function called download file. So what we take is, we take the URL, which is that Project Gutenberg one, and then we, in our data folder, we write it to a text file. So that is the one. If you see in our data, you would see that complete works, which was a text format of the file. And then we had another one. This was I was talking about. Did it show? Yeah, this is the one. This is the convert to chunks, which is a brute force chunk. So what we use is Python's regular expression module. So what we did was, if you see here, we did the multiple new lines. So we ended up in this one, and so we got this list. So this is for the chunking list, and then from util, then we used a advanced search model. So this had the business logic kind of what we. This is very good. 1 second. Oh, scroll up. Yeah, sorry. Yeah. So here, what and all we used was, for example, we used the sentence transformers and then the pandas for the data part, because we use data frames extensively here. And then we used Torch for the, and NumPy. I'll tell you why we were forced to do. We kind of discovered we had to use NumPy in the sense because we were working on CPUs. And when we save it to CSV, we got blocked there in the sense because when you write to CSV, you can't write tensors to CSV. So we had to do a conversion to NumPy, and then we'll have to do. And similarly, when you get it back, also we'll have to convert it to a tensor. So we had three modules. One is the build CSV data store. So what we did is basically we call the util the file object, and then the chunks has been done. Then we create the corpus embeddings on the chunks, like that is the one. And then we built a data dictionary, dictionary, Python dictionary, to have all this data inside and write it back to CSV. So here in the one time, just 1 second, so that so this is the phase 2. I will run the query. It takes a while. So, yeah, in Shakespeare, yeah, please. Where shall we meet? Question mark? Yeah.
In lightning, thunder, or in rain.
Space?
Like lightning, thunder, or in rain.
Thunder
Or in
or in rain. Okay. By the time I explain, maybe I'll. It might come.
Let's see.
Is it?
Let's continue. No, it's okay.
Okay.
Can anybody tell me which of the shapes?
I do not know.
Maybe that's there or not. I don't know.
So here what we did was this is the one. So based on the size of our embeddings, which is like 49,000 tokens. So what we did was we built a chunk ID, and then this is the one which I was telling you, where I had to retrieve the individual vector embeddings for each of this token, and we are going to store it in a list. So for CSV compatibility, we were using this one. I think if we are doing in GPUs, we don't have to do that. And then we populated the dictionary. So basically chunk ID list, chunk which has the chunks, vector embeddings, and then the document list here is like, we did the same one document. Yeah. Okay. Okay. Oh, okay. Figure, we should not take a note of figure. Okay.
See, at some phase I said use a database.
Huh.
SQL.
Yeah, yeah.
Writes to a file for you to use it.
Oh.
That's the later phase, right?
Phase 3. So
So that's why we wanted to stick with the phase.
phase 2.
Okay.
We wanted to stick with the phase, yeah. So that's why we didn't
Yeah.
use that. Otherwise, we would have gone for the chunking and then
Yeah.
everything.
No, break it up.
Yeah.
I hope it was useful to break it up into parts.
Yeah.
Sure.
So that's where we were able to identify like what's the limitations when you go
Yeah.
with the NumPy. All that.
So this one we went into a low. We didn't understand because we were in a Mac and it said MSU and CPU. Then it took a while for us, so we couldn't get out from that. So then what we did was we create a data frame of the dictionary and then we write it back to the CSV. So I would also show you the CSV which we developed. So if you see it these are all the tokens and you will see the vector embeddings for that. Right. And also on the, if you go on the rightmost, this is like, it went up to 650 MB. So it is kind of a little bit inefficient. You will see the title of this. So this is the store, data store, which we had.
Did the search results come back?
Let's go. Let me go. No, it's still running. You see that? It's running. It's running. It's running. It'll take a while. Because it's like an inefficient one on a data store on 680 to 49,000 tokens. Yeah, it is still, you see that it's rolling. It will take a while. So this is for the build part. No. If I'll explain to that. So the load part we are not doing it when we call it because this has been already done, right? So that's why you see the CSV. So we don't do every time the load. So yes, that will happen. Yes. So for example, so this is the load data store, which we had a utility method just to load it back to a data frame. So this is the one which will be called from Streamlit, this display queries. So once you pass a runtime query, so first we load the data store, we construct the query embeddings from the query, whatever it is. And then this is the part, as I talk back from NumPy back to Tensor, and then you'll have to stack it as well. So finally you'll have to stack it so that it comes into the stack. So you have a like comparison. So this is a little bit, I mean, we don't have to do this. We had to, since we are doing in CPU, we had to do all that. When we are GPU, we don't have to do all of this. And then uh, the rank, score, and chunk, rank and score, we do not have previously. This is going to be generated. So what we did was from the search results list, you create the rank, score, and the chunk list. And then we filter the record. So we use the pandas. I mean, few of us would have attended the data wrangling ASIF course here. We use the ISIN function of chunk ID. And then we made use of a copy so that the original data frame is not impacted by any chance. And then we added the rank and score. And then we dropped the index as well. So this is the one. And then I'll go to the UI part, which is we made use of Streamlit. And in Streamlit, we made use of the data frame part. So what we did was we first check if it's not an empty one. And then we wanted to reduce what data actually wanted. So we made them columns to display as a list. We created a subset of the data frame. And then since we had a link data frame, when we printed it, it came in a normal text format. So we wanted like a HTML1 there. So what we did was we converted the subset into a constructed a link. And then the data frame on the markdown, we made it to HTML. So subset. So that way we will see the link as well. But let me see if the search has even come back. Voila, there it is.
Let's click on it. Let's see what it's.
So that is a it did not go exactly to the like this is the link Asif, but it will not go exactly because it's just a link, not the marker chunk. But here is the chunk text, the answer. You see,
The answer, but if you click that, it will take you to that.
yeah, our thunder from the south. Shall and you will see the chunk tokens. Okay, when shall we? Yeah, but the ranking it showed is 0.49. Yeah, it is a 0.49, and the first one in the rank had 0.68. Our Thunder from the South, maybe our Thunder from the South took a higher precedence. We do not know. And this one is nothing but it takes us back to the document. Oh,
When you soon you'll learn how to improve on it. Click on the link of that.
yeah, sure. Oh, third one?
That goes to that.
No, it all everything goes to the same one. We did not have that.
You can cite in this file.
Yeah, this file.
The first few lines of the play.
Say it, Thunder. You can tell. Help me.
Like this, the Summer Nights.
Yeah, I don't know that at all. So lightning, right? Thunder. Can you tell me? I can type it here.
Lightning. So, lightning.
Lightning is there. No, it is like a single word.
Orient, right?
Lightning, thunder, or
Will you get
And
the
the first is
same
started at the same line.
order? I don't think so.
yeah.
Yes. No, this is at the very beginning, actually.
Yeah.
Oh, sorry. It is at the very, very beginning.
Okay.
But it doesn't matter, but it's just that it's one of the famous lines.
Okay.
Maybe we can search it to where shall.
Yeah.
You want me to
Yeah, it's at the very beginning, but control home or something like that. It is.
want to search?
Yeah, search it to where shall.
Where shall we?
Where shall we? Control F, maybe. With Control F.
1 second now.
I want to make sure that it found the right reference.
Yeah. Where?
Shall.
Here it is.
Yeah. Oh, no. Okay.
Where shall we?
Lay him.
Space.
Yeah. Shall we? Here it is.
Shall we take
Shall we?
Yeah. Where shall we meet in the morning?
Again. Oh, it's the wrong file. No. It is not there in this file. So it is in the Midsummer Night's Dream.
Okay.
But this is great. Yeah, in lightning, thunder, or in rain, chunk size. This is it. This is the one. So I think your hyperlink may have a slight bug.
Slide bar. Yeah.
Yeah, your hyperlink probably has a slight bug.
Sure.
Where shall we meet again? Yeah. All right. That doesn't matter.
Yeah.
All right. This is very good. Nice that you guys took Shakespeare. Extra points for you. I love Shakespeare. I love Shakespeare.
Thank you.
So, would you like to come in?
Thank you.
A lot of good work. Huh? You guys have put in a lot of effort to do this.
Yeah, just stop the sharing. Stop. Yeah.
So, guys, before the next team comes, I want to make an announcement. I noticed that most of you are sitting upon Macs. Some of you are sitting upon Windows. What you should do is, and this is what will happen when we give you the server, and our TAs will take you through the process of how to set it up. The beauty of this is you can run your Visual Studio Code on your laptop. So you have the full beauty of the Mac UI, but you're using the computing power of the servers Linux server that we give you. So you stay in familiar environment, but you're working on the server. Are we together? Right. You just use Tailscale, you'll tunnel into it, and everything you do, you're using the compute of the server, but to you, it will look as though you're working locally. So work in that mode. No virtual machines. I told you, Conway, that we give you what no company will give you, a really powerful bare metal, right? Just don't do crypto mine. That's it.
What is it called? Asif, you said stale. How do you
no, I'm
connect?
saying you will use Tailscale, and our TAs will set up sessions. We'll
Tailscale?
send you
Okay.
instructions. Yeah, Tailscale. Tailscale is it's basically a wraparound WireGuard VPN. Yeah.
Hey guys, My name is Mandeep, and I'm with Team Mosaic Minds. Can you guys hear me?
Yeah, if you could move the microphone a little close to you, because
Okay. Is it better now?
that's awesome. Thank you.
Okay. Okay. I'll share my screen. Looks like I'll have to quit Zoom and re-log in. Just a second. Okay. Uh, okay. Hopefully you guys can see my screen now.
Yeah, we can see.
Okay. Awesome. So what I did was there is this podcast that I listen to on and off. It's on Spotify, YouTube, everywhere. They tell you about general investment. They give you investment advice. So the first thing was how to get this data. Initially, because the phase one, I'm still on phase one, will complete phase two by a day or so. So not as advanced as the first two groups presented. But I went over and there is for Spotify, especially for Python, there is a Spotify module that you can rely on to get things like the title and the description of a particular podcast. Um, so what I mean, it's not as organized, but I did it in parts, and I had to comment out stuff. But basically, this is the code. You import the Spotify module. There is a web API. There is a website that you need to create your credentials on, where you get the client ID and the key to make API calls. Then after that, basically, I got that information, entered the URI for every episode, got the information in the form of a list and title and description as well. So in the end, I came up with this kind of CSV file. So there are about 120, 126 episodes that they have, 124 episodes. So my CSV consists of the URL, it has the description in there, duration, everything that was obtained. I haven't filtered out anything, ID and so on and so forth. And then there is the episode, the name of the episode, right? That has some text in it. So this is my kind of the short part of the code where all I'm going over is you can ignore the first one, but here it's a pandas data frame that gets created based on that CSV file. And I'm looping over and collecting the name and the description, and then embedding that, creating a list which has name and description, and then embedding that in the default model that we had in the other notebook, Distilbert. And then this is the Streamlit part. Right now, it's around, so this is the size of the embedding. So 125 rows and 768 columns. I'm just going to, okay, maybe I can just launch it like this. I'm just going to call it. So you can think of any query that you want with respect to investing. So I just did investing for kids, and it will right now only spit out the title, but I initially had description also in there, but I have to clean it up a little bit. But here you can see that the ranks are, they're somewhat relevant. Investing for a newborn, make your child a millionaire, stuff like that, right? Yeah, thank you. And the next step, we are four people. Yeah. And so the next step was, which is a bit difficult because I'm not relying on an existing data set, was to fetch the transcript. So if you look at this, every episode and this Spotify introduced, I think, a year or 2 year back, whereas every episode, if you click on it, there is a transcript page. So the idea is to, for every episode, gather the transcript and then brute force chunk it and, see how relevant it is. The problem that I was facing was this: Spotify does not have transcript related any method to fetch that, because these are pretty recent and that's a little bit old. So then what I did was I went to Selenium, had to resort to Selenium, and there, it goes and fetches based on the XPath tag. Sorry, here. It's basically web scraping, yes. So I identified the tag, and then just one of them, I need to fine tune this, but basically I have now those text files created for every transcription. I'll just maybe show you guys one of it. Yeah, so maybe we can look at the backup. So this is for every episode that they have. And if I click over it, right now I have, the way I have made it is, this is the episode title section, this is the description section, and this is where the transcript starts. And I have, like the other team, kind of chunked it. In my case, I have chunked it based on the date tag. Yeah. So again, regex split based on this kind of timestamp. Yeah. Yeah. So it will split it based on, hopefully, when one person is talking, if he doesn't go over, I mean, we'll get to know, but hopefully there is some semantic relationship there. But yeah, based on this digit colon digit. Yeah. So the regular expression, right? Yes. So that will be the next part. Create another CSV file and then try it out. Yeah. Thank you, guys. Thanks.
Thank you, Mandeep. Any team remotely, those of you who are remote, would one of you like to present? Anyone from the remote side?
Sure, I'll present. Yeah.
Okay, go ahead, Shirin. Nice. Shirin, who all are you in your team?
So, okay. We are the Latent Spice.
Oh,
and,
latent space. I like it. It's a
Latent
spin on
Spice.
latent space.
Yes, and we are currently, I know we cannot be 5, but we are 4. That is, we just formed a team just after lunch. Is Atisha, Vishal, and Kavita. Yeah, and
Nice.
okay, so unfortunately, I think this team was not formed before this assignment. So, but so let me share my screen. So the main thing was to actually the problem I fixated or I got fascinated by was the koan, 100 koans actually, and it took the book. This is the 100 koans book, and I felt it was tough because each koan is there. Master Kijo says something about it. Master Hakyun says something about it, and there's plain saying and some notes on it. So that's how each koan, hundreds of these are structured. I took a route, may not have been the optimal route. So I went into ChatGPT and asked it to split it actually. So I didn't use any, unfortunately didn't use any API on this, but I would at a later point. But so split it, and what it did ultimately is gave me 100 koans, each one in a dot file.
Oh, very nice.
So these are all the koans in dot files. And I'll just open up one koan. It's the bitten by a dog. So this is, it actually did a phenomenal job in splitting all of these. It kept on crashing because unfortunately it couldn't take that PDF is not huge in terms of the memory, actually. It's 12 megabytes, but I think it was kept on managing. I said, look, don't do 10 at a time, 5 at a time, just do 1 at a time. Can you do that? And you have to prompt it properly.
Sure. Chirag,
Yeah.
coming across as too small to see for people on the TV.
Oh, I'm
so make
sorry.
it much bigger.
Much bigger. I'll expand it. Yes. So this is one koan here.
They want to know, how did you split the PDF?
Oh, it was a ChatGPT 4.0 command, actually. I gave it a PDF and I gave it instructions saying, hey, this is how you will find every koan in the book. If you look at the PDF file, it is structured in a particular way. It has a triple star that's started, there's a content, and it ends with a note. So I first described how each koan is structured in that book. And said, this is the way you would chunk it for me. And then it actually went ahead and chunked it. So if you look at this PDF file, it had to do an OCR2 on it, okay? So this was a tough challenge for it, really. And it had to get rid of the initial preface and introduction and all of that. I directly said, so this is, if you look at it, okay, I told the ChatGPT I told it that this is the way it starts in double quotes, and Master Kijo will say something, Master Hakyun will say something. So it was described. Sorry.
Sorry, just a quick question. When you say you did this with ChatGPT, did you just write a prompt?
It was purely a prompt, but I gave a JSON in terms of how the document is structured.
Oh, I see. If you don't mind, if you can share the prompt, that'll be interesting.
Sure,
to see how
absolutely. Yeah, absolutely. So all that got done, and then I said, unfortunately, didn't have time to create a Python file. So this is what I did. I riffed off of the exercise that was shown by Asif, and this is all the toy corpus here. And here I fed it the documents one by one. Oh no, not this. Sorry. Homework 1. So this is where I said, hey, go read all the documents one by one, iterate through that folder and keep on reading it. And all the sentences were formed right here. And then I just printed the first one. What does the text explain? This is kind of the content, Master Kijo and all of that.
Wonderful.
Yeah. And then moved over to the search part. This is the standard one. It was 101. I don't know how. 101, it should have been 100. But one of them looks like I ended up repeating one koan actually. But here we are, and I'll start from here's our team actually. Layton Spice, Marlon Brando sitting with spices actually. If you look at it, this was generated in DALL-E.
Yeah, who is
Marlon
this
Brando Marlon Brando from Godfather.
Is that Asif? Come on. My son would have freaked out by now.
Marlon Brando from Godfather, actually. Yeah.
Oh, okay.
He's the Godfather.
Generated using DALL-E. I said, I gave it a prompt saying, tell me as if Marlon Brando is sitting in front of, owns a spice and he's selling spices to you.
That's amazing.
Anyway, so here we are, semantic search, the same setup that Asif showed us, in the same model and sentence embedding. It's 101, 768. And here's where the Streamlit app is. I'll kind of show it to you. So this is what it does. I'm running Streamlit inside of Jupyter Notebook itself, saying, hey, give me some text. So let's just say rain. And let's see what koan comes out of rain. And I need to run this. I need to run this too. Interesting. Okay, 3 koans hit. Let's just see which koans with 0.2, 0.9. Not good scores actually for some reason, but let's just see what happened here.
A 0.24 is a very high score.
Is it? Okay. Okay, I didn't know that. Okay, so the voice of the raindrops, that's one of the things. You can see that the monk asked Master Jesus, what is the voice of the raindrops? Jesus said the voice of the raindrops is the voice of the Buddha. So then there's Master Kijo's commentary on it. Every drop contains the entire sky. Master Haikun says, when you hear raindrops, you hear the voice of the universe. And then the plane saying, then there's the next one, which is, what is the nature of universe? So it kind of goes away from the rain if you get to see. So
as a person who loves rain, thank you for sharing this as your first quote.
Sure, absolutely. And the next thing would be, of course, to load this into chunking and all that. But I'm trying to figure out how chunking would be done. I haven't given it a full thought. I will rely on my team to come up with it. There are sections definitely in the document, but I don't know whether that's the right way to chunk, actually. So I think that's TBD at this point in time. Any questions? All right, thank you.
Very nice. Very nice. Yeah. People here are clapping. Wonderful. Great job. And which other team is left? Which team hasn't presented at all? Atisha, your team presented? Oh, you're in this team, Shirang. Okay. Okay. You got admitted today. You escaped. All right, guys. So is that it? Have we covered every team? Royal, which team are you part of? Did you choose a team?
I could not find anyone. I don't know. I messaged them in the Discord. Can I work alone?
You can work alone if you so choose, but there are teams that can take you.
Oh,
okay. There is a team of 3. Yeah. Yeah. So there's a team that Abdul Rahman and Mrinal. And what's the name of your team? Matrix. So there's a team Matrix. So Royal, it's up to you. You can do it on your own or you can join the Matrix team. There are 3 people. So you would be a welcome addition to that.
Oh, okay.
There is Jyoti also looking for a teammate. Jyoti and her brother. Right, Jyoti?
Jyoti, which team are you part of?
I think Pawan will be joining from next week. So it's just 2 of us for now.
Okay. So you want to be a team with your brother, is it?
Yeah.
Okay. So have you picked a name for your team?
Oh, not yet.
I'll stop the recording.